Okay, hello and welcome back. So we were talking about classes, which is very fancy. We got through structs, we started classes, and then the first thing that we made was this point class, right? So we were representing points as objects that then have methods on top of them. Oh man, we can say negate, and we can have it act on a point called P, and it will go inside of that one P object and mess with its x and y and leave everybody else's x and y alone, any other point. Okay? So it all looks like this, and we did it. We made a point class. And now is the time where I tell you that I was being very lazy as I did that. Okay? It's a very lazy thing to do to implement all the methods inside the point class themselves. Okay? That's not what we want. We would prefer, as programmers, to split things up, like we normally do now, into .h files, header files, and implementation files, the .cpp files. Okay, so that's what we want to do, and you can also even split things up in the same file, and maybe I'll show you that first. Okay, so the first thing that I want to do is go over here and let us open up, or at least copy over, the stuff from last time. Dun dun dun. What do we have? What do we have? I guess it'll be classes.cpp. And let's call it point.cpp here. Hopefully that'll all work out. So vim point.cpp, let's edit that. Hey, okay, so now we have point. This is the class point. And it has its negate method, its add method, and its scale method. Okay? So this was the lazy way. What we would like to do instead is bring out the methods, the member variables, the fields, they have to stay. But the methods, they can go somewhere else. They can go outside of the class. Okay? That is the idea. We're going to declare them inside the class, declaration, and implement them outside of the class. Okay? Potentially in a different file. So, I guess the first thing that I want to show you is how to do it in the same file. And we're going to need one new piece of syntax, which are these two colons, which is technically not new, but they're new to us, I guess, the way that we're about to use them. Okay, so I guess without any more talking, let's do the thing. So I'm going to take this negate method and put it outside of the point class. The idea is we're going to just declare stuff in here, okay? We're going to just declare inside the class. Okay, so watch me just declare everything. Go down here. Go down here. There we go. And then, let's see here. Then we're going to take these out. Okay, they've been declared. We're telling C++, hey, you exist. We're saying, hey, here are these three methods that we're going to define eventually, but we're going to implement them outside. So here's the idea. We're going to just take them out, but we're not done yet, is the problem. And I'm going to show you just what is the problem in just a second. So let's save that. Do that. Okay. You'll notice that there are a lot of red underlines in my editor. It's like undeclared identifier x. What is x? We have no clue what x is. Do you see that the second I said these exist, yeah, that's fine. But the second I took them out, what do they look like now? I think if you think long enough, you'll notice that this looks just like a normal function. Ooh. That's the problem. To C++, this is just a normal function now. It has nothing to do with this class anymore. We need to tell C++ that, hey, this belongs. This is the negate method. It's not just a random negate function sitting out here. Okay? That's the idea. We have to tell C++ that that the function below is really a method. And that it belongs to. It belongs to the point class. Okay? And the way you do that is to put two colons. You remember the standard cout, and we used namespace standard for that. I want you to think of this as an apostrophe s, cout belonging to the standard library. It's like the standards cout. We'd like to make the points negate. Yeah? That's what we need to say here. We need to say point : negate. And now underlines go away because it's like, oh yes, this is the negate method. It belongs to the point class. There is the relationship. It's points negate function. Okay? So I want you to read those 2 colons as an apostrophe s. If that makes any sense at all. Let me put these in between quotes. That might be helpful. Wee. Boop. Boop. So it's the points negate function now. Okay? So, yeah. The idea is, the game that you have to play now is, you just say class name : in front of all these functions, and they're no longer just functions now. They are methods. They belong to the class. They are member functions. Okay, so I'm just going to do that to everybody now. Point : add. And now suddenly the underlines go away. Point : scale. And take my word for it, the underlines went away. Okay? And everything else still works just fine. Okay? We declared the fact that these methods will exist somewhere. Then we went and defined them. And then down here in main, we can use them as normal. P and Q, they're points. We just made them. P.x, P.y, we can set those things. And we can call these methods just as we normally did. We just implemented them in a different place. That's all. Okay? No big difference. So, let me compile this now. This was called point.cpp. We'll just call it point. And bam, it does all the same stuff. Okay, so that's one way to do it. Now, let's break it up further. Let's do a .h file and a .cpp file for all this. Okay, maybe we'll even do a main file. So let's do, let's make a new folder. Make dir point. It'll be like the point library. Oh shoot, sorry. Point, I don't know, lib for point library. I can't have one with the same name as something that's already there. Can't do that yet. Okay, so now I can say, let's move everything into point lib. Oh, that won't work, will it? Point, move it there. Oh, I think it already did it. It just complained on the last one. Okay, so now we're inside of the point library folder, and I have the same files. Now let's make a main.cpp as well as a point.h. Okay, so now I have all these things, and I'm going to put the main function in main.cpp, and then we're going to separate the point class into the declaration and the implementation. Okay, so point.cpp is the thing that has stuff right now, so I guess we might as well start there. So this is the declaration of the class. This goes in the .h file. And don't forget your header file guards. So there's no infinite inclusion. Beautiful, beautiful. So this is where we declare the point class, just as usual. You know it's a declaration because it ends in a semicolon, yeah? Isn't that funny? So this is the declaration. And then we're going to go and implement it in point.cpp. And oh man, we already did. Nice. And this is the time where, you know how I told you have to customarily include your header file? Most of the time, most of the examples that I've shown you previously did not require that. But now we do require it, because it doesn't know anything about what point means yet. That's defined somewhere else. We need to include point.h now, for this to even have any hope of working. Okay? That is it. And now we are home free. We can say int main, take this to the main.cpp file. Bam. Well, if we want to use cout, we got to include iostream. If we want to use it without the standard : we have to use namespace standard. Oops. And then if we want to use points, we have to include point.h. Okay, it's all the same as we were doing with functions, but now we're doing it with classes. Okay, so include point.h, so this file has any clue of what point means now. Then we can go and implement all the functions, which are really methods now, member functions, that belong to the point class. So that's the standard way of separating your concerns. Like, this is what the programmer sees who wants to use the point class. They don't care about how these are implemented. And then we, as implementers, we touch this file and we can make it work. Okay? And then main.cpp actually holds the program that's going to run. All right, so let's compile everything. And remember, to compile, we give all the implementation files. So it's g++, standard equals C++17, point.cpp, main.cpp, and you can call it whatever you want. Okay, let's do that. Copy that, paste it, and oh, oops, I need to go inside of this folder. Point.lib. Let's try again. There it goes. It's compiled. Now it's in main. I guess I can get rid of this point file. And everything is all the same again, but take my word for it, it's prettier, okay? It's much cleaner. There's a short file with the main function. There's a short file with the implementation of the point class. There's a short file with the declaration of the point class. That's really nice. I promise you that's very, very nice. Okay, so that is the way to properly implement a class now that we're all on the same page. And now let's talk about that weird public thing. I had to say public for some weird reason, and let me show you a different option now, okay? So by using public in our class, we gave complete access to our methods and member variables. So we were able to say p.x equals 42 somewhere else other than the implementation of the class. Maybe this is like in main. That's totally fine. We can access the x because it's public. And now, it's my turn to tell you that that's a horrible idea, to make the member variables visible for the user to go and use the dot and change. That's a very, very bad idea, because sometimes there are illegal values, like maybe the user was going to set it to -42, and we don't allow that in our program. We don't like that at all, but the user is able to change it just like that. What if we could make it so that that can't happen? So the user cannot touch the member variables. If we ever want that to happen, we can use private instead. Okay, I guess to make it all the same, let's use a colon again. So if we don't want users to mess with some parts of our class, some parts they need to be able to use, like p.negate, that's totally fine, p.scale, etc., etc. But the member variables, usually we like to make them private, and that keeps the user from being able to touch them. Okay? So, here's the secret. Anything that you want the user to never be able to touch, you say private. And anything that you want the user to be able to use, you say public. Yeah. Yeah, there we go. So, private things the user cannot touch. They're only accessible when you're inside of the class, inside of one of the methods. Then you can access them, but only then. Okay, and then public is accessible always. So it's access control. You're like giving a backstage pass to people with private, and then you're giving like a fancy pass for everybody, like a ticket to the normal show with public. Hopefully that makes sense. Okay, so watch what this means now, because it's very, very interesting. Dun dun dun. I can still access all of those private things inside of the point class, because we should be able to do that. We're implementing the class, of course. But in main, this is where the problem happens. hey, these are now underlined. What does that mean? If you look down here, what it's saying is point.x, or points x, is private within this context. Ooh, that means we can't access it. That even means it won't compile. Isn't that nice? So if we didn't want the user to touch these things, that's what we do. Okay, we use private instead. But now the question is, well, how are we going to give them things? Like, how are we going to let the user, like, edit this stuff? And the answer is a little bit farther down. I don't know if I want to get there yet. We're going to use getters and setters, have different functions that do this. Okay, so let me go back to normal, and we'll do that in a second. Okay. Dun dun dun. So, just to heighten the suspense for a moment, let's go back to normal, the silly way of doing things, and then we'll get there again. So it was the H file that I changed. Dun dun dun. Eventually we're going to change this back to private. Okay, so now everything's fine. It compiles. We're happy. We'll fix this later. Okay, so the next thing I want to do is test this point class. That's very, very useful. And we would very much like to do that because who knows if it even works. Yeah? So let's remember how to test things. We write a bunch of little what's called unit tests to test a little bit of our program. We write essentially a mini program to do whatever you want to test. So this is a badly worded sentence to, I don't know, to check one small thing, let's say. So the idea is you're going to run the program in your mind. You have those powers now. And then you're going to make sure that whatever it's doing in your mind is what really happens in real life. Okay? So that's going to tell you what the program should do, like what you should be expecting. Okay? So it's always this game. You always prepare what you got with what you expected. Okay? You always compare those two things. So for example, here's one test. Like, let's test that, I don't know, we make a point P, and we make sure that P.x is set to 42, and P.y is set to 43, and then we negate it. Then we want to make sure that P, in real life, has an x and a y that are negative 42 and negative 43. If those didn't happen, if those two things didn't happen to P, then negate has an issue. And so this is a test that tests the negate method. Okay? So that is how we can test the class. Okay? That is what we would like to do. So let's do that. Let's test the class a little bit, and maybe we'll do that in the main function, right? We'll make all our tests here. So we'll do, like, I don't know. First we need to assert true, that's for sure. Void assert true. It just helps us make our tests. We have a Boolean value that we want to expect to be true. We're asserting this fact. And then a description of the test. And then we'll say if B is true, the test passes. And give the description, just to be nice. Otherwise, we'll say failed instead. Okay. Yeah, I think that's a good assert true. And now let's do void test negate. And we'll do what we were talking about. We got a point P. I guess I don't need these anymore. We'll just run our tests instead. Test negate. So make a point P.x is 42, P.y equals 43, and let's have an extra nice test, because maybe, like, we only ever make things negative. Maybe we never make them positive again. So let's test negate like this. So let's assert true now after negating P that, well, what do we want? What do we expect to happen now? What should P look like? Well, it should have negative 42 as its x and positive 43 as its y. Assert true that P.x is equal to 42, and, no, sorry, negative 42, and p dot y is equal to positive 43. And if that's true, we pass the test, and this is, let's just call it test negate. Why not? Okay, so this is now our one thing that we're going to run. We're just going to run this one test, and hopefully it passes. Okay, bam, and bam, passed test negate. Wonderful, wonderful. Let's test something different. What else do we have in a point? Maybe let's test scale and call it a day. Okay, so let's just write what we're doing. Let's test negate and scale. You can try add on your own. Okay, so where were we? Let's test scale now. And I don't know, let's make something nice and small, like 2, 3, or 2, negative 3, that's fine. And now we're going to scale p by, I don't know, let's see, let's just scale it by 2. So the idea is we are going to multiply p's x and p's y by the scaling factor. So because of this, p dot x should now be 4, and because of this, p dot y should now be 6, or sorry, negative 6. So let's try that. So 4, oops, and negative 6. And this is now test scale. Okay. I think that should do it. Yeah, so we expect p dot x and p dot y to change to 4, negative 6. Let's make sure that happens, and that's our test. Hey, all right, so that makes me happy. It looks like it's working. That is what we want. So those are 2 nice tests of our methods. All right, so yeah, let us continue now. Okay, so I have some weird terms for you now. Okay, so the first one is called encapsulation, and that's something that classes gives to us. Okay, using classes, it allows us to encapsulate information. We get to bundle, that's kind of the key word. We bundle the data of our class, like the little member variables, the fields, with the methods that operate on that data. So those are your methods / member functions that directly access the data and potentially change it, or at least compute something nice based on those. Okay, so yeah, the idea of encapsulation is not only does every point, you can think of it this way, it's not technically true, not only does every point have an x and a y, but you can think of it like it has its own personal negate method. Technically, they're all sharing, but they know which one has which variable. Like they're not going to go and change q's x, they're going to change p's x. Then we have scale, then we have add. You can think of this as one big package, and like every point, in fact, every point looks like this. It's got an x, it's got a y, and it's got a negate that's going to affect that x and that y. Same with scale. It's got an add that's going to take this point and add it to some other point. It's going to remember. It's going to know how to access this x and this y, how to operate on the data that it has. Okay? So yeah, I want you to think of it like this for now. Points hold the functions as well as the variables. Okay, so that's really nice. And then the next thing that I didn't quite tell you enough about yet, we're going to have to get to that in just a second, is public versus private, information hiding. So the point of that is so that we can make it so that the user doesn't do anything stupid. Because we do not ever trust the user. You never should. And we want to make it so that the user only sees just enough to use the class properly. We don't want to give them the implementation of anything. We don't want to let them touch our underlying implementation, our member variables. Oops. We would like to just give them some methods to use and not let them touch the x and the y, for example. Okay? So they only get the public stuff, and we get to control what's public and what's private as the implementer of the class. Yeah? That is the point. Okay. So, and the whole reason for that, besides not trusting the user, is that you can go and implement a faster or a better version of your class. Like I can make a negate that works twice as fast maybe for some reason. If I ever discover that, nobody's going to care because they're not going to see anything different. My public methods, they're still going to work just the same. Negate's still going to do the right thing, even if it's twice as fast, okay? Even if it's better on memory. I have that choice. I can make it better, and it's not going to wreck anybody else's program that's based on this class, okay? Nobody's going to get angry, and that's the point. I can even make it worse, and as long as it gives back the right answer eventually, not too many people are going to care, okay? So that's information hiding. And coupled with encapsulation is kind of like the idea of classes. This is why classes are so powerful. We get to do this kind of stuff. Okay? So you're going to be using object-oriented programming, or at least complaining about it for the rest of your programming career. I can promise you that. Okay? So now let's talk about stuff that we already know. So string and vector are classes. Did you realize that? Isn't that nice? Because of this, we have operations on each string, on each vector. String s equals blah. We can see out blah at 2. Sorry, s dot at 2. Can't we? That's a member function. What? We're using dot. See? That's just a method. And if we had a vector v, vector of ints, we can say v.size, and that'll give us back 3. That's another method. What? What? Isn't this beautiful? We were using classes all along. Even if you don't believe me, you can go look up vector. It's like, oh, class vector. What? It's all there. This is all member functions. Can you believe it? And you can definitely assume that there are no fields that you're allowed to see. Did you realize that? This class is not letting you look at any of its underlying member variables. We don't get to see any of that. The only things that we can do to a vector is based on its methods. We can push back, sure, but we can't do like dot underlying array at index 0 or something, okay? That doesn't exist. We have to call methods to interact with a string, to interact with a vector. Isn't that interesting? So now, like, the whole, the curtain has been drawn. Everything makes sense now, hopefully. So now, let's get fancy, okay? Are you ready to use the full power of classes? We're going to information hide, we're going to do cool stuff, and the first thing that I want to do is implement what are known as getters / accessors and setters / mutators. So these are both interchangeable words. These are the same, and these are the same. I usually say getters and setters. Okay, I prefer those, but these are like the technical versions of those. As you know, everybody likes Latin roots to say technical things. So here's the idea. Once you start restricting access to your member variables with private, for example, you have to start adding public methods to go in and get the stuff, to go in and get the x value, because now we can't say point p and then like p.x anymore. We can't do that. That's not allowed. Okay. Now we have to say p.get x or p.set x and give it the value 42 or something. Okay, that's the idea. So we have to give these now. We have to add accessors and mutators. We have to add getters and setters. So getters get back the values. They get them for you, and they return them of your private variables. And setters set the value of a private member variable. And the whole reason you might want to do this is so that you can change how things are working. Okay, this makes sure you have control over the exact values. Okay, and this might not seem like much right now, but I can promise you it's a very, very nice thing. Because maybe you didn't want users to set x values higher than 40. You would disallow this. You wouldn't have this work. and that is your right as a programmer. That you deserve. Okay, so let's do this. Getters, accessors. We're going to go to point.h, and now we're going to get a getter and a setter. Let's add getters and setters now, because I'm about to make this private. Now we can't touch these. User cannot touch these. So let's see what's about to happen. Let me go here. Can I reload the file? Yeah. Look, I can't use any of these anymore. I can't say .x. I can't say .y. I cannot do any of this. It's not allowed. So what I'm forced to do is say actually, let's say how about that? Yeah, I have to say set x, and I have to give it 42 now. You see that? I can't say p.y equals negative 43. I have to say p.set y. Or you can call this whatever you want. It could be like set underscore lowercase y if you wanted to. This is the standard way of doing it. Negate still works because it's a public method. And now I can't use this anymore. I can't get the value with just dot because it's a private member variable. But I can say get x. I can say get y. Yeah, that's the idea. So 2 and 3. Oh, sorry, negative 3. And then we'll say get x. Get y. Okay, now we just have to implement these setters and getters. Okay, let's do that. So the getter is the easier one. That just gives back the value. So get x, for example, all it needs to do is return x. Yeah, it gives back the value. And so the type is obvious now. It's a double. It's going to give back the x. And this one will be get y, so find x, replace it with a y. There are our getters. And our setters, well, set x, for example, it's going to take a new value for x. Double new x. And it's going to go and set the x to be the new x. Yeah, that's all it needs to do. And so it doesn't need to return anything at all. It's a void function. It's a void method. Okay, so that's our setter. And let's do the same for y. Okay, so this is all it is. It's that simple. If you want to get the x, just return it. If you want to set the x, well, just set it. And this gives us access to like restrict the values that x could ever become, to maybe do some logging and like print out that the user just called this method and we're about to give back x to them. We can do a lot of cool stuff when we restrict users from directly accessing this private data. Okay, these actual member variables. Okay, so yeah, this is me implementing it lazily. Let's do it normally. This needs to go in the .cpp file. And remember that, there we go. We need to prefix all of these with point : : Yeah. And then the very last thing is to get rid of the implementation here, of course. Oh no. And so now I'm gonna do oops. There we go. So now I've just declared them here, and we've gone and implemented them down here. Okay, so now I think it should be happy. Who knows why it's not, but we will get there. And now I'm using set x and set y here. I probably just have to reload everything. What if I change this and resave it? Nah, we'll find out. Yeah, now it's totally happy, and if only it would let me. Yeah, let's just get out of all of this. Whee. Now it's happy again. Okay, underlines have gone away. And so everything's still the same. That's the beauty of it. Everything is still the same, but now I'm using these setters and the getters outside of the actual class. Okay? Hopefully that makes sense. This is going to set x to be 42. This is going to set x to be negative 43. Negate's still a public method. We can get the x, we can get the y, and still test them. Okay? And so everything should still be the same. Yeah, our tests still pass. It's just a different way of writing things. Okay? That's the idea. Just a different way of writing things. All right, we have covered a lot of ground. Let's keep moving. Now, we can also watch out for ourselves, our own backs, because not only should we never trust the user, we should never trust ourselves. Remember that too. That's very important. What we can do is we can put const in our methods, okay? Not just for parameters. So I told you how to do this already. Like, make a function, works for a method as well, with a const parameter, and that means you can't touch this when you're implementing things. That's quite nice. But what you can also have is the equivalent for when you don't want a method to ever touch its private member variables, where that would be a bad idea, or you don't want to accidentally overwrite something, and by that something I mean a member variable, which is not the same as a parameter or a local variable. It's a member variable. It's our x and our y. What you can do, and there's a special way of doing this in a method, is you put const, like not in the parameters, you put it after the method. It's really weird, but it looks like this. You say like what's a function, what's a method that you would not want the user to, or you would not want to update your value of x, for example. That would be like, definitely like get y. It should never update x, and it should also never update y. It should just get the value back. So you say double get y, and then you say const right here. That is the key. That keeps you from updating your member variables inside this function, and it doesn't make sense to ever want to do that there, so it would have been a mistake otherwise. Okay, so const is very nice because it makes sure that in this function, which should not be changing anything because it's not a setter, it makes sure that it doesn't. Okay, so yeah, it's just really helpful when you're testing things, because now you can be very, very confident that a method is not going to touch your member variables when it should not. So usually getters should always be const. You'd have to give me a very good reason for this to never, for this to not be true. Okay, so let's go and do that. This is all we have to do. We say get x const. Get x should not be allowed to change x or y. Okay? We'll do the same thing for get y. Well, set x and set y, we're kind of out of luck with them. They have to change things. Negate also has to change things. Scale has to change things. But add also shouldn't be touching us. It should be giving back a new point using our values. Okay? So it should also be const. Yeah, it's just going to use our values to make something new. It should not update x or y. Okay? That's quite nice. That's something to want. And then all you have to do is add it in the implementation as well. You gotta say const here now. You gotta say const here now. And that's really it. It's just easier on you now to do things, because watch me do this now. It makes sure that you don't do something stupid like this. You can't say like x, well, it was, well, whatever it was, it's now 42. Yeah? That does not get allowed here, because if you try to compile it, or your editor is going to show you the errors before compiling, it says cannot assign to non-static data member with const member function. It's a const method. It's a const member function get x. We're not allowed to do this. Isn't that nice? We don't want to be able to do this, and it helps us make sure that we don't actually accidentally do that. Okay, so that's not allowed. But it was allowed before. Before I put this const, I could have done that if I wanted to. I totally could have. Isn't that crazy? We don't like that, so that's why we put the const. And this is in a weird spot because it's talking about the member variables. It's talking about x and y, which they're not part of the parameters, right? So that's why they go in that special place at the end. Okay, that's all. Everything still works. Let me confirm to you that it all still compiles and runs. Yeah, does the same stuff, passes the tests. It's just better. I promise you that it's just better now. Okay, so I think that is where I want to leave us for now. We're going to come back and we're going to implement the counter library now using classes instead of just functions. Okay, so it's something that we already know how to do. We've already done this kind of stuff, and now we're going to do it in class form. Are you ready? So we are getting fancy for sure, and I will see you in the next lecture.